Okay, welcome to the class. So we are today the first day of the class. So we are doing igcse-edexcel's chemistry. From the first lesson to last lesson, we are going to conduct and cover in this class. Um, Here, first of all, let's go through the content, right? So I know most of you guys haven't gone through these things because uh, you guys were just go through the middle school classes, and now you are in the all other classes, right? Grade 9. Okay, so these are the topics that we are going to discuss. Now, remember, you guys have a slight idea about chemistry you are going to learn because you have done something, I believe, in the middle schools. So, a little bit more we are going to discuss here. Right? So, the first lesson is going to be on our syllabus, principles of chemistry. So I'm writing all the notes on the screen. So with me, you must write your notes, right? Time to time, I may ask you to share your notes with me. So on the principle of chemistry, we are learning about states of matter, right? So on the states of matter, we are learning few things. The three states of matter. So you guys are aware of it. At the moment, you are doing much more things in the middle school. Then diffusion and dilution, solution, solubility, and we are doing a small practical. So we will discuss on the states of matter about these things. Then elements, compounds, and mixtures. Compounds and mixtures. We are going to discuss the differences and the similarities between them. Elements, compounds, uh, and mixtures, right? And then we are moving on to atomic structure. I think in grade 8, you guys are learning a bit about these things. Then the periodic table. Okay. I will share separate note with you, but this is the note that is vital. A short note. I want to write the notes with me, right? The periodic table, then the chemical formulae, equations, and calculations. Then we are discussing about ionic bonding and the bondings, right? When electrons are completely shared or taken, forming oppositely charged ions. The attraction between these opposite charge ions are called ionic bondings. Then covalent bondings when the electrons are shared. Right? Covalent bonding, about these we are going to discuss. So are you guys following me through up to here? Hello? Can you guys hear me? Yes. Are you writing these things? Are you writing these things, huh? Then we are moving on to metallic bonding, the bonding in the metals. Something similar to ionic bonding. The only thing is this is the electrostatic attraction between a cation and an electron, right? Metallic bonding. Finally, we are learning about electrolysis. Electrolysis means using electricity, we are going to break our solutions. Electrolysis using electrical energy. In other terms, a reverse of a battery, right? The battery is doing generating a voltage, a current. Now, using a voltage or a battery, we are breaking a compound in a solution. Electrolysis, right? Okay. So these are the principles of chemistry, right? So general knowledge on chemistry. Okay. In the first 2 3 months, we will be discussing about these things. But anyways, today we will be starting on atomic structure, right? More interesting stuff. These things you guys are aware, but we will be covering it. But we will be starting on atomic structure, right? Uh, I hope you have taken some notes on these things. Later, we will be sharing your the other note. This is what is important, right? The second topic is inorganic chemistry. As the name says, right? Inorganic. Organic means carbon. Inorganic. About compounds and and atoms except carbon. Inorganic means that. Organic means carbon. Inorganic means chemistry about everything of the periodic table except of carbon. Right. So you must be wondering what about carbon then? Carbon we are learning under a special topic. Carbon is the most important element in the periodic table. Right. So for that we are having a special branch. Organic chemistry is for that. So under inorganic chemistry we are learning about group one. You know a bit about it. In the middle school you guys have studied alkali metals. Then group seven. So later in the principles of chemistry we are learning what these groups are. What is a group? What is a period we are learning. I know in the middle schools also to a certain extent you guys have learned. And then halogens, gases in atmosphere, reactivity series, extraction and uses of metals. Right? Reactivity series means we are making a series, a ordered series from highest reactive element to the least reactive elements. We are only discussing about very few elements, highest reactive to least reactive, right? Starting from potassium to end with gold or silver, right? Reactive series. We are later discussing in detail about these things. Extraction and uses of metals, and Uses of metals. Acids, alkalis, and trans titrations. Alkalis and titrations. What titrations also you guys must have studied a bit. Huh? Under chemistry in the middle school. Metal extractions are also you are learning, right? But here we are learning more theory, more science about it. More than this just facts, we are learning the science behind it, right? And then we are learning about acids, bases, and salt preparations. Acids, bases, and salt preparations. And then we are learning about some practical chemicals tests to identify some of these elements and gases. Chemical tests. Okay, right? Then by the time you move on to the grade 10, we are learning on physical chemistry. Right, under physical chemistry, we are learning about energetics, rates of reaction, then reversible reactions and equilibria. And equilibria. Okay, nothing much, right? Under physical chemistry, there's nothing much um, compared to other stuff. Okay, finally, physical chemistry means actual physics in chemistry, right? Okay, physical chemistry means physics in chemistry. Under physical chemistry, we are learning about physics. There's a bit of physics. Remember, there's not much of a difference between physics and chemistry. So what's different in chemistry and physics is uh, in chemistry we are learning the physics in atoms and molecules. That is the difference, right? So in physics you guys are learning what is happening around you. In chemistry we are learning about the physics, the invisible physics. You cannot see atoms and molecules, right? In small scales, right? So that those things are discussed in the physical chemistry part. Some of these units are both covered in physics and chemistry. There are few overlaps. Very few overlaps are there between chemistry and physics. Common units are there. Very few things are there like that, right? Okay. Finally, you are moving on to organic. Some students may tell you it is hard, but for me, I will tell you most interesting and the easiest. But it's kind of different because you guys haven't got the chance to learn about organic chemistry in the middle school. So it is brand new. right? Bit of physical chemistry you guys have studied, and the energetics, energies, right? A principle of chemistry also you guys have studied a bit in middle school. Inorganic chemistry definitely you guys have studied. You guys have studied more on inorganic chemistry in the middle schools. But this thing is brand new for you, organic. So that is why we are learning this mainly at the grade 10, right? So under organic chemistry, you guys are learning the introduction, right? So the carbon containing compounds. Crude oil, we are learning about crude oil, right? We mainly import from Middle East, and how to make petrol and diesel we are learning. Extraction, fractional distillation we are learning. And then we are learning the very important thing. These are may look new for you. We are learning some different types of compounds called alkanes. This is a hydrocarbon section. You will learn later what is a hydrocarbon. And alkenes, alcohols. Everybody knows. Learning about what is an alcohol, chemical. What is an alcohols? Uh, Carboxylic acids. These are acids, but it contain carbons, right? Carboxylic acids, very weak acids. Esters, synthetic polymers. Oh. So these are the stuffs you guys will be learning. Okay. Right. So since it's our first class, we will start off with one of the most interesting stuff. We'll be starting off with atomic structure. Right. So under principle of chemistry, we are moving on to the subtopic called atomic structure. It's under principles of chemistry, atomic structure. Under atomic structure, we are learning about atoms, their definitions, and structure. Also, we are calculating their relative atomic mass. Calculate relative atomic mass. Okay. So let's move on to under atomic structure, definitions and structure. definition and structure. Okay. Okay. Now, what is an atom? And if I ask this question, you will give you many answers. What is an atom? Right? Atom means the smallest. Yes, 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 yes. Speak up, speak up. Very good. A substance forms a molecule. Yeah, yeah. Not that you are not wrong. Actually, a substance that is making up a molecule. Yeah, in a way that is okay. And nothing wrong with it. Um, right. Actually, uh, one of the smallest particles of an element. Right. If you take, it is actually a building block. Right. It is actually a building block. But if I tell you it is the smallest building block, it is wrong. There are much smaller things than atoms. Even atom is made out of small particles, subatomic particles. So I would call it a small unit, as you said, a small unit molecules are made of. So molecules are making uh, a matter, right? Right. So basically, uh, one of the smallest smaller units that is making matter, right? So atoms are combining each other and forming molecules, and molecules combining together forms other stuff, including you and I, right? But if someone tells you atoms are the smallest unit, no, they are much smaller than that. So you have to be very careful. It is one of the small particles, but not the smallest, right? Small particles, uh, small particles of an element. Right? Now you must be wondering what is an element. Now for now, keep this in mind. Element means your periodic table have, you must have seen it, right? You must have seen some cubes. So each cube represents an element, right? Each cube represents an element. So everything we have around is made out of different groups of atoms, right? Each group is called an element. So likewise, there are about 136 groups of atoms, right? Not atoms. The whole universe is made out of uncountable number of atoms, but even though the universe is made out of uncountable number of atoms, there are only about 136 groups of atoms to make the whole universe, right? So each group is symbolized by the a cube in your periodic table, right? So that is called an element, right? So what is an atom? A small particle of an element containing electrons surrounding a nucleus, right? Later we will discuss what is an electron, what is a nucleus, right? Small particle of an element containing electrons surrounding it, containing electrons. ENS means electrons, right? Electrons surrounding a nucleus. Right? Nucleus. That is an atom. A small particle of an element. What is an element? We'll later discussing in further. What is an element? Containing electrons surrounding a nucleus. Then your friend said a molecule, right? So molecules are made out of atoms. Molecules uh, combining two or more atoms, two or more atoms, chemically combining two or more atoms chemically, a unit called a unit called molecule is made. So it can have at least two, or it can have many, right? Many number of atoms combined together chemically. A unit called molecule. So it is like this. You must have seen grapes, right? You don't see a single grape. If grape is an atom, a bunch of grapes are what? A molecule. So each of these grapes are connected to each other. In some bunches you have hundreds of grapes. In some bunches you may find only five or six. But they all are each connected to each other. It is called a pond. So just like you don't find a single grape itself, you find bunch of grapes. So in the universe, you don't find a single atom. That atom is always connected to a different atom or the identical atom. It could be many, starting from two to many number of atoms, right? Just like a bunch of grapes, right? So the stem of the grape connecting each grape to each other, the stem that is connecting each grape to each other is the bond, right? So under bonds we are learning there are many different types of bonds. Okay, all right. Then let us move on to atomic structure. So atomic structure we are learning about what is an atom, right? Now remember, I think you know, right? So at the center you have things called protons, right? P means protons. And with them they have something called neutrons. Neutrons. N means neutrons. Okay. So they are always together, just like the sun in the solar system. Around them we have A much smaller particle called very small and electrons, right? They are rotating around, orbiting around the nucleus. E means electrons, right? They are orbiting around. Depends on the type of atom. There can be single orbit or many orbits. Single or many orbits. Each orbit contains different number of electrons. Depends on the element, right? This orbit is called energy level low shell. Shell low energy level. These electrons are orbiting around this, right? Now remember, in the first shell, you can have only maximum of two electrons. Now you must remember this. Second level, you can have maximum of eight electrons, right? Third one also eight. Fourth one, you don't need to learn the maximum number, right? Because you are learning up to 20 elements. The 20th element has another two electrons in the outer shell, right? 20th element has another two electrons orbiting around. Right? Now I will give a small task. Let's see. If there's an atom called A containing three electrons, it contains three electrons, atom called A. How many electrons are there in the first shell? How many electrons are there in the second shell? Fine. That atom called A contains only three electrons. Send me your answers, right? There's an element called A. It contains three electrons. How many electrons are there in the first shell and how many electrons are there in the second shell? Fine. In the first shell, the maximum capacity is 2. You can have only 2. Second shell, you can have a maximum of 8. Hmm. Very good. The maximum you can have 3, no? So this element called A contains 3 electrons. So first 2 electrons will be first shell and the remaining electron will jump to the second shell, just like this. Now I am going to give you a little task. Right? Now you are learning up to first 20 elements. Each of these elements have a number of electrons, uh, 1 to 20. 1, 2, 3, 4, 5, 6, 7, 8, right? 9, 10, 11, 12 up to 20. Right? You have 20 atoms you are learning, 20 elements you are learning. So each of these, the first atom contains one electron, second one contains two electrons. I want you to write how many electrons each atom contains. For example, each shell. The first one electron in the first shell. Second one, two electrons. Third atom, two and one. Fourth one, two electrons in the first one, another two in the second shell. Likewise, you can go up to four shells, right? Here I told you maximum number of electrons they can have, right? 2882. Fill it up to 20th, right? Fifth one also I will do 2 and 3. Likewise, up to 20th. Each shell, how many electrons are there? Just first shell, how many electrons? Second shell, how many electrons? If there's a third shell, how many electrons are there in the third shell? Can you write it down and send me the answers in the group? Can you do it? Okay. Send your answers there. Okay, I have your answers. Right. So I most of the answers I got are correct. Right. So let's write and see. So I did here. If you have 6, 2, 4, 2, 5, 2, 6, 2, 7, right? 2, 8. Now it's a time. Now if you have 11 electrons, now the maximum capacity is 8. So therefore you must go to 2, 8 and 1, 11. Then again 2, 8, 2, 2, 8, 3. So you must know how to write the number of electron in each shell for first 20 elements. This thing you should know, right? So this is called electronic configuration. Later we will discuss about it, but this thing you should know, right? 4, 2, 8, 5, 2, 8, 6, 2, 8, 7, 2, 8, 8. Then you have what? You are up to 18 electrons. 19th one is 288 1. Then 288 2. Up to 20 only, right? Okay, so each shell has what? First shell 2 electrons, second one 8, 8, and third one is 2. So the fourth shell can have more electrons. But we don't need to learn about it, but because we are learning up to 20 elements, right? So you should know up to here how many electrons are there in each shell, right? Okay. I hope it is clear. Any questions from here? No, right? Now let's move on to the next part, still under here. Now I told you now in the nucleus, right? It is made out of protons and neutrons, and the electrons are orbiting around. Now these are called subatomic particles, right? Subatomic particles, proton, neutron, electron. Okay. I hope you are writing this right. Now the thing is, these are also having a mass. Right? They are very small, smaller than a atom, but they are also having a mass. But the thing is, their masses cannot be measured in kilograms. Right? Their masses cannot be measured in kilograms. Can you tell me why? Why you can't measure in kilograms? Why? You can measure it, but it doesn't make any sense. If you measure a weighing scale for measuring kilograms, will you be able to measure it? You put a proton and measure. Can you measure in kilograms? What will happen then? Will you be able to tell a value? Yeah, you will be able to tell a value. It will be very little value. It will be like 0.00000000000 kilograms. It doesn't make any sense, right? If you are using this unit is too big, too big to measure the mass. Too big to measure the mass. The mass of this. So therefore, they had to come up with a different unit. They call it not kilograms, relative mass. Relative mass, right? So you call it as relative mass. They are just comparing the masses of each other. That's it. Comparing the masses of these subatomic particles. It doesn't just like kilograms. We don't tell relative mass. For example, protons. What they did was they said, okay, the mass of a proton is one, right? Then they found mass of a neutron is also same to a proton. Then what should be the mass of this neutron? What is the mass of one neutron in relative masses? Find, write and send me, right? And then they measure the mass of electron. I will not tell you. They found electrons are, if you take a proton and you divide it into 200 parts, the mass of this one part is equal to the mass of an electron. Right? That is what they found. You take a proton, you divide into 2000 parts, the mass of that one part, what you have divided, is equal to the mass of an electron. Now, the relative mass of proton is 1. It is always 1. Now, compare to this proton. What is the mass of a neutron and electron? I will tell you again, the mass of a neutron is equal to the mass of a proton. Mass of an electron is what? When you divide the proton into 2000 parts, each part has the mass of an electron. Fill this up and send me. Relative mass of a neutron, relative mass of a electron. If that is the case, can you guys do it? Find the relative charge. Right. Neutron does not have charge. So it is 0. We call it neutral. That is why it is called neutron. Neutral. Electron, similar quantity, opposite. So they call it as negative one. Negatively charged. Negative one. Okay. So you must remember, memorize this chart. Huh? Mass of a proton, mass of electron, relative mass, relative charge. So these things you must remember. Okay. Now let's move on to another interesting one. There are a bit of calculations, right? Okay. Uh, Put the heading as calculating protons, neutrons, and electrons. Now, if I tell you the element in the periodic table, you must be able to tell you how many electrons are there, how many protons are there, how many neutrons are there in that element. Let's see. Calculating protons, neutrons, and electrons. Here's the catch. Now remember, now you have studied in middle school. Now each element is symbolized with a what? English capital letter. If there are two elements with the same English capital letter, the second element they discovered, they name it with the second letter of the Latin name. Right? So that is why some elements have two letters. First is capital, second is simple. Right? Let's say there's an element called X. There's no element called X, just hypothetical. If you look at the periodic table, to the left hand bottom, you must see a number, right? Uh, I'm going to call it Z. And to the left hand side, to the top pole, there's a little letter, number. I'm going to call it A. And it has a meaning. Now here, this number is called mass number. Mass number of the element. Mass number means a mass of the atom in relative atomic masses. Can you remember previously we did relative atomic mass? The mass of this atom is equal to, right, total number of neutrons and protons. Total of number of total number of neutrons and protons. Total number of neutrons and protons in the nucleus. In the nucleus, is equal to mass number. Now I'll tell you, if the mass number is 3, right, how many protons and neutrons are there in that nucleus in an element? Over here you found 3. How many protons and electrons are there? Not separately. What is the total number of protons and electrons? Send me in the group. Okay. Or you can even tell if the mass number is 3, the number of neutrons and protons is equal to what? Hello? Are you there? If the mass number is 3, number of protons and neutrons is equal to what? Hello? What is the value here? Yes? Any answers? If the mass number is equal to total number of uh, neutrons and protons, if the mass number is 3, total number of protons and neutrons are equal to 3, right? The number at here it is called atomic number. This tells you number of protons in the nucleus. Number of protons in the nucleus. Right. Okay. Atomic number means number of protons in the nucleus. I will give you this question. Let's see who's giving answers. There's an element called lithium. You find these two numbers. Now let's I want to find number of protons, number of neutrons. Find find the number of protons and neutrons. Okay, send your answers, huh? Right. So you don't need to write the equation also, right? So atomic number, mass number is equal to number of protons plus number of neutrons. Mass number is what? Now, number over here 7. Number of protons are equal to what? Atomic number. Right? This is the atomic number. So number of protons is 3 is equal to number of neutrons. So so you subtract 3 from here, you are getting what? 7 minus 3 is what? Number of neutrons. Number of neutrons is 7 minus 3 is 4. Okay. And you must be wondering what about the electrons. Remember, later I will tell you. Right? If there's no charge here, you know ions no. For example, there are something like lithium 2 plus, like this. This is the ion. Later we are learning, right? Now over here there's no charge, right? So we can take it as 0. So it's a neutral atom. There's no number over here. Can you see? So therefore, in a neutral atom like this, when there's no charge, no value at the right hand side, if there's no value here, right? In that case, all the time, number of protons and number of electrons are the same. So therefore, since since the element is neutral, since the uh, atom is neutral. How do you know atom is neutral? Because there's no charge here. See now, we haven't put in symbol. This is 2 plus. Here no, so it is 0. You should don't put the charge here. It is 0. Since the atom is 0, always when the atom is neutral, number of protons and number of electrons are always the same. Then in that case, how many electrons are there then? This is a neutral atom. See, no charge. How many electrons are there then? Yeah. Send me the answer here. How many electrons are there? Send it. Hello? Very good. The number of electrons are equal to number of protons. So therefore, number of electrons are again 3. Now I will give another question. There's an element called Y. Atomic number is 29. Mass number is 63. Find the number of protons, neutrons, electrons. Okay. Find it. Alright, these are the answers. Number of protons are equal to number of atomic number. Atomic number plus when you subtract 29 from 63, you get the number of neutrons in the nucleus. Since it's a neutral atom, since there's no charge, number of electrons and protons are the same, right? So you get the value as 29. Right. Now you go and you will check the periodic table and you should do it yourself. You must find the periodic table. Okay, I'll tell you a magnesium. 1224. Find protons, neutrons, and electrons.